Okay, but now let's get started with the speeches. So please welcome with me the first speaker, Rahil Samlal from South Africa.
Hello, thank you. All right. Good day, everyone. My name is Rahil Samlal from the Republic of South Africa, and I'm here today representing the University of Pretoria for something called the Dr. Derek Gray Memorial Award. And my research today covers methods into combating facets of antibiotic resistance by investigating an alternative treatment protocol for commonly occurring pathogenic bacteria. It's not news to anyone that each country around the world faces a similar dilemma with regards to antibiotic resistance and other microorganisms. And antibiotic resistance can be defined simply as bacteria changing in response to certain medications used. One such consequence of this phenomenon is individuals who are infected with pathogenic bacteria who, with a low level of initial infection, still face the consequence of not responding to antibiotics that were once used to treat these very easily to treat infections. It is a global health concern that bacteria have been exposed to a wider spectrum and greater concentration to antimicrobials, and thus this increases the likelihood of them to develop resistance to these types of antimicrobials. All of these factors together contribute to the alarming statistics of antimicrobial resistance. I wanted to combat this issue by investigating novel solutions which provided effective relief but had a low probability of causing resistance itself. I studied specifically a plant species in the family Canaceae called Canna indica, and the immune response chemicals which it releases called phytolexins, as well as the effects of probiotic gut bacteria or pre-adapted probiotic gut bacteria. The certain pathogens which I studied were called Escherichia coli, commonly known as E. coli, methicillin-resistant Staphylococcus aureus, also known as MRSA, and Listeria monocytogenes. So what are phytolexins? Phytolexins are organic compounds which are released and secreted and accumulated temporarily by plants in response to any kind of pathogenic attack. This phytolexin which I extracted has enzyme-inhibiting properties. An enzyme is a protein which accelerates or decelerates certain functions in cells, and in certain pathogenic bacteria, there are specific enzymes which are responsible for increasing the metabolic rate and reproductive processes within the bacteria cell, thus making it more virulent or harmful. And the extracted phytolexin, which goes by the scientific name 3,15-dihydroxy-2-octadecene, is an enzyme inhibitor. So it can target these enzymes, attach to the substrate site, and inhibit its function. And the second method was the use of probiotic gut bacteria. And a well-studied mechanism of probiotic gut bacteria is that they function through the release of something called bacteriocins, which are a source of organic antimicrobial, which are released by lactic acid bacteria. The experimental design was as follows: extraction and purification of the phytolexin using steam distillation and decantation. So steam distillation is a separation process used to purify temperature-sensitive organic compounds, such as the phytolexin which I extracted. The biomass of the Canna indica plant was collected, so the rhizome or the root of the plant was collected, and the phytolexin was extracted. Since the certain plants release a lot of different chemicals, an identification test called the Lucas test was conducted to ensure that the correct phytolexin was indeed going to be studied. Thereafter, the plates and inoculum for the probiotic bacteria as well as the phytolexin were prepared. This diffusion method was used to determine the results. My hypothesis was...
Round up.
Yeah, last
Okay.
slide. My hypothesis, which stated that the probiotic gut bacteria would outperform the phytolexin and that the pre-adapted probiotic bacteria would yield the higher zones of inhibition, was indeed correct. From this study, it can be concluded that the phytolexin as well as the probiotic gut bacteria both possess antimicrobial properties, and that the pre-adapted probiotic bacteria is able to perform at the same strength as antimicrobial drugs. With progress in my research, I'm hoping to study thorough mechanisms of action, therefore advancing my research. Thank you so much for your time. Okay.
Stay here. Okay, now we have some questions for Rahil. Rahil, stay on stage.
Yes.
So, if there is any questions, we have someone who will go around with a mic. Anyone has a question? Yeah, over there. You have a question?
Yes, sir?
Hello, this was very interesting. But generally, through evolution, we've found that many different species evolve different forms of proteins capable of doing the same function. How do we? So, doesn't that mean that these bacteria could potentially develop these enzymes which are similar but different in certain ways, which allows them to overcome this antibiotic properties?
Okay, yes, I'm assuming you're talking about natural selection and the evolutionary process. I have considered that, and this is why, with the progress in my research, we're hoping to find the mechanism, so the specific ways that these compounds interact with these antimicrobials. I hypothesize or postulate from my studies that these compounds can change in response to the strength of the bacteria. Therefore, I concluded that the natural selection factor will have to come in later, because I feel like with the nature of the compound, it's unlikely to develop resistance, or it's definitely going to develop resistance, if it will, in a much shorter time than current antibiotics used. Thank you for the question.
Yeah, thank you.
Do we have any more questions somewhere? Raise your hand. Any more questions? No? Then we thank you again.
Thank you so much, everyone.
And